Hello and welcome to SudoKanard. In recent videos, and by that I mean the videos I'm doing in English with my sublime French accent, I've mainly focused on somehow rather difficult Kakuro puzzles. The ones by Puzzle Maestro, also known as Freddie Hunt, were really difficult actually. Some of them were insanely difficult. And I've done some medium difficulty puzzles, and I thought I should do a bunch of easy puzzles and put them in a video. And those would be more beginner friendly, I mean. So I just browsed the website Puzzle Master, Grandmaster Puzzles, sorry, and I chose puzzles with standard timings that were very low. So this one was set by Serkan Yürekli, who's a permanent contributor on Grandmaster Puzzles. I think he's Turkish, well, that's what his name suggests. And so this Kakuro is really a short grid, and you can see that the timings are very low. So my claim is to be on the verge of expertise. So my goal is to be close to this timing, but obviously you have to add the time I spend explaining what I'm doing. So that's it for this prep talk. Now let's get right to it. So where shall I begin? This 16 clue is very restricted because it has to be 7 plus 9. 16 clue with 2 digits has to be 7 plus 9. And it meets the 23 clue on this cell, and the 23 clue with 3 different digits has to be 6, 8, and 9. So you see that the only common digit is the 9, so 9 has to go here, and this is a 7. Now those 2 digits must be 6 and 8, but you can't put an 8 in a 13 clue, in a 13 sum with 4 different digits, because then if you put an 8 in here, then the remaining 3 cells should add up to 5, but the minimum sum you can make with 3 cells is 6. So this can't be an 8, this has to be a 6. This is an 8. And now the remaining 3 digits must add up to 7, which may only be achieved with 1, 2, and 4. And I'll only put 2 and 4 in this cell and 1 and 2 in this cell, because 4 here would need another 4 here, which would be a repeated digit. 1 here wouldn't be enough to fulfill this 11 clue. Now, is there something I can eliminate? These ones would be completed with 9 and 7, 9 plus 2, 7 plus 4, and this one with 7, and these 2 with 6. Something interesting is this 17 clue, because the only possible digits here are 6, 7, and 9, completed with 9, 8, and 6, respectively. And that's nice because you can see that those 3 digits are 6, 7, and 9 in some order. So these 4 digits add up to 30, and those 2 digits should add up to 4, which can only be done with 1 and 3. This 3 clue must be 1 plus 2, And this 11 clue must be 1, 2, 3, and 5. 3 can't go here because it would require another 3. So it has to be 1, 2, or 5 paired with 5, 4, and 1. Now, this alignment, this column has no clue, so we have no clue as to what we can put in here. But this has to be 1, 2, 3, or 5. This 21 cell, this 21 clue, is the sum of 6 different digits, and the only way is to sum all digits from 1 to 6. That's the only decomposition. This 23, once again, is 6, 8, or 9, but you can't put a 6 in here. It will need another 6, so it has to be 8 or 9, paired with 4 or 3. 6, 8, 9 in the remaining cells. Oh, but this has a minimum of 6. But if I put a 6 here, then this is a minimum of 8, which makes 14, and you will need to have at most 2 with those 2 digits, which is not possible. So this can't be a 6. So now the minimum is 7, and 7 plus 6 plus 1 plus 2 makes 16. So the minimum case fulfills the conditions, so the minimum case has to be the correct one. So this is 7 and 6 together with 1 and 2 in some order. Now we have a 1-2 pair in here, so 1 and 2 are in those cells and are excluded from the other cells on this row. So this can't be a 1 and this can't be a 5. Oh, and this produces another 1-2 pair, removing 1 from this cell and 3 from this one. Now that's a 5. Now those cells must be 3, 4, 5, 6 in some order. Well, we still need to work some more. Or this 7 is completed by an 8, which yields this 9, this 8, this 4, this 5, this 1, this 2, this 1, this 2, and this 1. Now those need to be 3 and 6. And my bet is that this will turn out to be a 6, but we have to go full circle to resolve that. So now this 11 clues, so 11, like in this case, it has to be 1, 2, 3, and 5, but only 5 is enough to fulfill this 13 clue. So this is a 5, that's an 8. Now, only 2 and 3 are enough to fulfill this 11 clue, but 3 would produce a second 8 in this row. So that's not a 3, that's a 2, producing a 9. Those must be 1 and 3, but 3 wouldn't fit in a 7 clue. 7 has to be 1, 2, and 4. So that's a 1, that's a 3. Those 2 cells must include a 2 and a 4, but 4 can't go here because it would have to repeat. So that's a 4, that's a 2, that's a 6. Now this 4 rules out the 4 from this cell. Now we have a 1-2 pair, which make this a 4, this a 7, this is a 6, that's a 2, that's a 1, and let's finish this. 6 must go there to fulfill this 35 clue. Now 6, 7, put a 9 in here and a 6 in here to fulfill the 15 clue. So that's a 3, that's a 6. Now, how do we finish this? We have 26, we need another 5. It can't be 3 plus 2 because we already have a 3, so it has to be 1 plus 4, and this one puts a 4 in here and a 1 there. So my overall timing was much higher than this expert timing, but I'm not sure what it would have been if I had not been compelled to explain all of this. Let's move on to the next puzzle. Oh, and obviously, as usual, I put links to all these puzzles. This one was set by Fidel Zapico. It's the first Fidel Zapico puzzle I featured on the channel. And it has this very nice Z shape or Z shape according to the pronunciation where you are. Well, in France, it's just Z, which is not quite the same. Okay, so you can see those timings. These are really analogous to the timings of the previous puzzle. So where shall I begin? These 3 and 4 clues have only one way of resolving, and I put them this way to show the correspondence. And this 4 clue also includes a 1, so they will have to be this way. If we were on the left-hand case, then we must be on this left-hand case, and conversely. This 8 doesn't use a 1, so it could be 2 plus 6, it could be 3 plus 5. I don't see how to resolve this yet. But something nice is that we have this sum and this sum, so we have the total sum of those 14 digits. But we also have those sums. So by adding those and subtracting those, we have the total sum of those 4 digits. Let's have a look at what it produces. So the sum of those 2 rows is 70. The sum of those 5 columns is 37, which make these cells add up to 33. And 33 has to be with this and this in some way, because that's the sum of 17 and 16. So we have those digits somewhere around here, and this 19 clue says that those digits are 7 and 9, because 8 and 9 would make this 17, and we would need to fit a total sum of 2 with those 2 digits, which is impossible. So those have to be 7 and 9. And 8 and 9 in some order, 9 and 8 this way, with a correspondence between the 9s. And those have to be 1 and 2, paired with 5 or 4. Now, how do we move further? Still not easy to say. Oh, let's have a look at what's missing here. The total sum of digits from 1 to 9 is 45. So we can deduce what the missing digits add up to. In this alignment of 7 different digits, we miss a total of 6. The 2 missing digits add up to 6. So they have to be either 1 plus 5, or 2 plus 4. But we know there's a 1. So 1 plus 5 is not what is missing. What is missing is 2 plus 4. So this 2 is impossible, and we're in the right hand scenario. And something similar disambiguates the night conundrum on this row. So what's missing? The 2 missing digits add up to 14. So they have to be either 6 plus 8 or 5 plus 9. But we know there's a 9 among those digits. So 5 and 9 are in this sum, and 6 and 8 are not. So this time the disambiguation is on the left-hand side, which balances all this stuff. Now we should be able to resolve this. Now, with 7 and 9, that's 16. So these 5 digits must add up to 15, which is 1, 2, 3, 4, 5. Now, where can 3 go? 3, oh, no, this 3 would produce a repeated 9, 4 would produce a repeated 8, so that's a 5, together with a 7. We need now 4 and 3, but 4 would produce a repeated 4, so that's 4 and 6 and 3 and 5. And we can check out that those digits really add up to 39. Now, this is 9 plus 8 is 17, so those 3 digits must add up to 7, and it can't be done with a 5, so that's 4, 2 and 1. Those must be 2 and 1, so it's this way, and 9 here. Now, to fulfill this 18 clue, we need another 17, which is 8 plus 9, so that's this way. Oh, and we don't know what to put here because there's no sum here. So if there's no sum, then it's not needed to solve the puzzle. Now, we need another 3, which is 1 plus 2. But now, if this is a 2, then we need another 16. And if this is a 1, then we need another 17. But 17 is 8 plus 9, and nothing would be suitable for this cell. So it has to be a 2. And now we need 16, which is 7 plus 9. And only 7 goes here. That's a 9. Now those digits should add up to 9, and those 2 should add up to 12. There seem to be several possibilities, actually. So I think we should have a look at those rows. I do the same logic, the same arithmetic as at the bottom. So those two rows add up to 70. And those 5 columns add up to 63. Seriously? Oh, so those 4 cells add up to 7, which has to be 3 plus 4. So those must be 1, 2, and 3. Repeated 1 on diagonals, and so 1 and 2 somewhere, 1 and 3 somewhere, and this 21 clue disambiguates somewhat the lot. Sorry about that. Now, if I put 1 and 2 in here, then those 2 digits should add up to 18, which is impossible. So those have to be 1 and 3. And those should be 2 and 1. Now that's 4. So these ones should add up to 17, which is 8 plus 9, providing 6 or a 5, but now those two digits add up to 3. Those should add up to 23, and 5 would not be enough. So that's a 6, that's an 8, that's a 9. And now we have 9, so this is another 16, so 17, so that's 8 plus 9, and that's a 3, and that's a 6. And we really didn't need this sum. Now let's have a look at this. Oh, that's the same logic now. We are missing 6 on the 45, so the two missing digits must add up to 6, and the missing digits shouldn't include a 1, so they are 2 and 4. That's really the same logic. So I remove this 2, this 1, this 3. And here I need here 8 and 9, 8, and here 9 and 7, 7 and 9. And there again we are missing 14, but 9 is somewhere on this row, so 9 and 5 are not the missing digits. 6 and 8 are the missing digits, so I delete this 8, then this 9, this 7. And how do we complete this? 1 plus 3, that's 4, obviously, so these 5 digits should add up to 35, and the only possibility is with 9, 8, 7, 6, and 5. So we are missing 6, 7, and 5. 7 would provide a repeated 1. 6 would provide a repeated 2. So that's a 5. That's a 3. We need now 6 and 7. 6 can't go here without repeating the 6. So that's 6, 7, 5, 4, and 5. And that was pretty much the same logic as here. I wonder whether there's some kind of symmetry, but there might be some kind of shifted symmetry, I think, actually. Oh, that's interesting. Well, that was nice, and believe it or not, here is a third puzzle with, once again, similar standard time just for reference, but a different layout this time with this H in the middle. And let's have a look at this puzzle. I didn't solve those puzzles prior to making this video, just for the record. Not that it matters so much. So let's start with this 30 clue. 30 with 4 different digits has only one way. It's 6, 7, 8, and 9. But now only 6 can go here to make a 7 sum. So that's a 6, that's a 1. Now this 11 clue is 1, 2, 3, and 5. And we need some digits here and some digit here to add up to 14, and the only possible way is to add up the maximum digits. That's 5 here and 9 here. Now those have to be 2 and 3, but 2 wouldn't be enough here because the maximum here with 3 digits is with 7, 8, 9 is 24. So this has to be at least 3. So it is 3, it is 2, and those digits now are 7, 8, and 9. 9 can't go here, 9 can't go here because of this 9, so 9 goes here together with a 6. Now those are 7 and 8, but 7 can't go here without repeating the 2. So that's an 8, that's a 7, that's an 8, that's a 1. Now we already have then 17. We need another 13 without using 8 or 6. So those digits are 8, 4 and 9 in some order. Now, what next? Let's have a look at this 42 clue. Just like on the previous puzzles, I reminded that the sum of all digits from 1 to 9 is 45. And now we have a 42 clue with only 7 digits. So there are 2 missing digits, and those 2 digits must add up to 3. So the missing digits are 1 and 2. So there's no 1 or 2 in there, but this 4 clue is 1 plus 3. So this has to be a 3, and this is the 1. Now, the smallest possible digit here is 4, and here it is 2. And the smallest digits give the required sum, so they have to be 4 and 2. And the same goes, the same. So this 4 disambiguates this 9-4 pair, but now look, it's the same every time. This digit has a minimum of 5, this one a minimum of 3. Now, this one has a minimum of 6, and this one a minimum of 4. Now, this one has a minimum of 7, and this one a minimum of 5. And only 6 can go here, only 8 to complete those sums. Oh, that was a very nice setup. Now, something is telling me that these should be really similar, but not that similar as to be the exact same logic. What should we do? This 30 sum, is it really what's needed? No, this 8 and this 6 are useful for this 14 clue, because 14 has to be either 8 plus 6, which is not possible because no digit is available for this cell, or 9 plus 5. But 5 wouldn't fit in a 30 clue because the correct digits are those ones. So it is 9 plus 5 in this order. Now this 16 clue is 7 plus 9, but 9 is not available, so that's 7, that's 9. And this digit could have been placed right from the get-go, because the maximum digit in a 12 sum is 6, and it's also the minimum digit in a 30 sum. So this has to be a 6. This is an 8. Now those 3 digits must add up to 7. So they are 1, 2, and 4, but only 1 can go here. 4 would be too much, and 2 would repeat the 2. So that's a 1, that's a 3. We need 2 and 4, and here we need 1 and 2. 1 would make this a 5, so 1 here, 2, 4, and 2. That's 31. So we need now another 7, which is made with 4 and 3. And with this 4, we place a 4 on the left, a 3 on the right. Now this 4 clue is 3 plus 1, and this 3 disambiguates. This 6 clue, that's different logic. That's beautiful. This 6 clue should be 4 plus 2 or 5 plus 1. But 4 plus 2 is not available because of these 4s. So this is 1 plus 5 in this order. That's really, really nice logic. Now, this 8 sum has 3 possible ways. It could be 8, 1 plus 7, 3 plus 5, or 2 plus 6. But one and 3 are both excluded from these cells. So it has to be 2 plus 6 in some order. This 12 clue, there's 3 ways of doing 12. That's 3 plus 9, 4 plus 8, 5 plus 7. But you see that 3 and 4 are excluded from both cells, so it has to be 5 plus 7, and because of this 5, there's 5 here, 7 there. Now, the remaining digits here are 2 and 6, but 6 here would produce a repeated 4, so this is a 2, this is an 8, that's a 6, that's a 2, and the missing digits are 9 and 6, so this makes really a sum of 30. And this completes this third puzzle by Hatice, Esra, Aydemir, whose double Kakuro was featured on the previous video. Well, those were not that easy, I think. Those were really nice puzzles with easy mechanics for experienced solvers. But these are not easy puzzles for beginners, I think. Well, those are really nice small puzzles, small Kakuro puzzles, displaying a variety of somewhat straightforward techniques. And I hope you enjoyed them. Thank you for watching this video, and see you pretty soon on SudoKanard.